You receive a phone call from the bank that you have been left an inheritance from your great aunt Bertha. How nice. The account has a 3% interest rate. First of all, we're dealing with money in an account, so we're here. Obviously, that's what the lesson is about, but it never hurts to put things in a larger context and make sure you know why you're using the formula you're using, and we're dealing with money in an account. So here goes. Let's list everything we know. The account had a 3% interest rate, so 3%, let's go ahead and call it what it is, that's 0.03. And compounded quarterly, that happens 4 times a year, and they originally invested $2,500, and it was in the account for 35 years. And then how much money is in the account? This one's going to be pretty straightforward. So basically, again, finding A, not going to be a very difficult process at all. We've already done this twice, so let's go quickly. $2,500. By the way, you're about to get a lot of money out of this. So again, keep in mind that the n variable happens in the denominator here and in the exponent. So 4 times 35, which is quite significant. All right, let's do it. Your great Aunt Bertha has bequeathed to you $7,116.19. We're going to round to 2 decimal places because it's money unless they tell us otherwise. Okay, number 4 though. You receive a phone call from the bank that you've been left an inheritance from your great Aunt Bertha. Apparently you had 2 great aunts named Bertha. The account has $4,155.31 in it and had a 3% interest rate compounded quarterly, $2,500 originally invested. How many years was the money? Oh, okay. They're asking a different question this time. They are saying that the amount is now $41.55. This is where things change. $41.55.31 had a 3% interest rate, and it was compounded quarterly, and $2,500 was originally invested, and then how many years was the money in the account? We don't know T. So we're going to find it. So let's find it. Let's see. Same formula. A equals P. 1 plus R over N to the N times T. And we're going to plug in everything we know, but the thing we don't know is time. And this is going to get a little bit tricky. But we've seen this in a different context, but we've seen it. 41.55.31 equals 2,500. 1 plus 0.03 over 4. Raise it to the 4 times T. Okay, well now what are we going to do? Well, we're going to solve. So solve for what? Solve for time. And my T variable is in the exponent, so we're going to have to use a logarithm to get it down. So the best way to do that is to start putting this into truly exponential form. We're going to divide by 2,500. Now, I've said this before in a different lesson, and it's worth repeating again. So whenever you do this, you might end up with some crazy decimals that go on for days, and don't round. You may want to round on your paper, but don't round in Desmos or on your calculator, because you'll lose some accuracy when you do that. You'll lose a lot of accuracy. So even though I could be tempted to put 1.66, I'm going to put 1.66. I could put 1.662, but when I actually do what I need to do with this number, I'm going to use 1.662124. Because there's a logarithm coming, and if you round too early in a problem that has a logarithm, you're going to lose some accuracy, like a tremendous amount of accuracy. Okay, everything in parentheses here, nothing in there involves a variable, so let's just figure out what that is. 1.0075, and we're going to raise it to the 4t. This is exponential form. It may not look like it because of all the decimals, but it is. So we're going to write it as a log. Log base 1.0075 of 1.662124. That is equal to 4t. Okay, we're going to find out what this is. I have no idea. Basically, this is a question saying 1.0075 to what power would give me 1.662124. Yeah, try that in your head. See how that works out. So let's not. Let's go up and grab those numbers. You can do it this way. Get to where you want the number to go and then go up and grab it. And that is going to very obviously round to 68. Now, I know a minute ago I said, now don't go rounding. It's time to round. 67.9999, let's just be logical. That's 68 equals 4t. We're going to divide 68 by 4, and that is going to give us 17. So t equals 17. 17 what? 17 years, because we're dealing with time, and in this formula, time is always measured in years. Always, always. Okay, let's do the next one. A long time ago, you lent a friend $100. This is sounding familiar again. Different friend. He's going to pay you back at 4% interest, compounded semi-annually. He paid back $114.87. How many months did it take him to pay you back? Okay, don't know. So we need to find out what T is, and then when we find out what T is, our answer is going to be in terms of years, but they don't ask for years. They ask for months. So we'll need to be really careful for the specifics of what they're asking. So A equals P, 1 plus R over N to the NT. And let's start plugging in the numbers. 114.87 equals 100. 1 plus R over N to the NT, and N is 2, because it's semi-annually. Semi-annually happens twice a year. All right, let's divide by 100. This is kind of a waste of ink, but I'm going to write it anyway. When we divide by 100, that's going to move that decimal. Don't type that in the calculator. Just go 1.1487. There we go. Equals, we can do this in our head too. 1 plus 0.04 over 2, that'd be 0.02. 1.02 to the 2t. All right. We are now in exponential form. We might be tempted to say we were in exponential form here, but there was some simplifying to do first. We had to divide by 100. Now, instead, let's use a log. Logarithm. Log base 1.02 of 1.1487. That's equal to 2t. And we're going to get something. Don't know what. Let's find out. Log base 1.02 of 1.1487. And logically, that's 7. Now you could say, oh, well, if you go 3 decimal places, it's 7.001. I hear you. I engineered this to where the answer would be 7. So let's just go with 7. 7 equals 2t. So t equals 3.5 years. We're done. No, we're not. They don't want years. They want months. So if something has happened for 3.5 years and we need months, then we're going to do, well, 3.5 times 12. And when we do 3.5 times 12, we're going to get 42 months, even though there's a number 41 in the corner of the page. That's the page number. There we go. 42 months, not the 41 that was there.